Hi, my name is Daniel Rabanibiu Madangit. I am from BSIT DIT 27 and I am from AS4 as well. Hello ma'am, nice to meet you and classmates who are watching. And today my experiment goes to, my current experiment is how do glasses produce ringtones? Now, we are tasked here to basically which glasses produce ringtones and what factors affect tones produced and why. Now, disclaimer, before you go further to this video, I must inform you, I don't have any wine glasses. I only have drinking glasses, and those don't work because it doesn't produce the same kind of tone and vibrato, and I will explain later why such things won't work because of such limitations. I don't have them. I'm sorry. I'm just gonna use someone else's footage. Hope that's okay with you, ma'am. The reason, in the factual sense, is that I've played with these things before, thick and thin, and even normal glass, right? And in my point of view, and in my observation, and in my conclusion, as my understanding of the physics of this, is that the thin rim will produce lighter sounds, more lighter tone, right? Because due to its shape and how it's constructed, it will obviously produce sound. Just checking there. Sorry, I'm really sorry. Back on track. The reason why that the differences between start again. The differences between wine number glass 1 being thick and numero dos thick o big-bico is basically that the thicker glass has more tendency to lose more lower vibrations. What do I mean by this? For example, we got a thick note on the first string of the guitar, the really thick line, right? The thick string of the guitar, it will produce bong. Same principle here, and yeah, the same. It applies pretty similar because of its shape and its size, and once you hit it, boom. Same with the thicker wine glass, it will go because of the vibrations made by my finger rubbing towards the friction caused by the water and my finger, therefore producing vibrations, therefore producing sound due to its shape of the object. Because when you just rub your hands on things, it will take glass for instance. No matter how much you try, it won't, because it doesn't have resonance, or it doesn't vibrate to make sound. Same with the thin glass, where you rub it and go. So obviously it produces sound, but in a lighter tone. Obviously that explanation was from me and my experience. I didn't explain it well. Well, let's use our notes to compare my findings to further shorten my explanation, because I was so passionate of speaking from experience that it didn't actually explain anything. I only saw what happened. Therefore, thick object produce thicker sound or bass sound, and thin object produce lighter sound or higher tone sound. Now, here we learn from our module, right? The pitch is the highest and lowest of the sound. So that was the thing that I was trying to, the word I was trying to find, which is pitch. Now, pitch is the highest and lowest of sound, and the higher the pitch of the sound, the greater frequency of the source. Now, here's where my experience and this module combine into one form of education. Is that my experience is that due to its thinness, it is a higher tone of pitch. But in here, meaning that due to its thin composition as a glass, it can produce greater frequency because of the vibrations are greater, because it has less resistance to the vibrations upon my finger rubbing towards the rim. So not obviously the loudness is pretty high of this because it will be natural for things with higher frequencies to be either loud or brighter. See the similarities between sound here? So obviously when we go further down, there's timbre and tone. The tone, two between different sounds, and that are the same as pitches and loudness. It helps us to identify what produced the sound, and is the reason why we can determine the differences between the sound produced by a violin and a trumpet, a guitar and a ukulele, cymbals is whatever. Basically, my observations were correct and my assumptions were correct that the thicker the glass, the thicker the pitch is, because it can resist more vibrations, therefore it produces less frequencies, therefore the sound is either bass or low or not at all. Whoop-de-doo. So obviously speed and sound here is another factor which differentiates, is because that due to you just going on a menial speed of, if you go further it will produce more frequencies, therefore it has a tendency to break because the thin glass will shatter upon a maximum frequency it can handle. It go kablooey. For the lower frequency one, it will produce even higher sounds, but it won't break because of its higher thickness of the object, the way it's composed, the way it was built. It can withstand higher frequencies, but it will just amplify the bassness of the tone. It will grow louder, but the pitch is low, but the frequency is heightened, meaning it makes a bigger wave, and it produces a much louder sound. Much louder sound, and obviously it produces sound and it won't break, which is great. Here are the key factors that affect sound: density, already discussed this, elasticity. Now here's what's interesting. This wasn't found in the light part. It was only exclusively for the sound. Why? Because sound waves move faster than in elastic materials. Since the molecules of these materials return quickly to the original positions after a disturbance, this is the reason why top portion of drums is made of elastic material. Going back on percussion and, density of sound, going back to our glass theory, it's not elastic, it's solid, but the way it vibrates is like a tuning fork. It's not technically bending per se because it's elastic, but more it's vibrating, but due to its solid state, dense enough to resist breakage, it still will go back to its original form. Now temperature. Obviously temperature is important, but since we're always here in the Philippines where it's always 36 degrees Celsius, it doesn't really affect that much. You can still hear me through my microphone speaking to the speaker, and obviously you can hear the electric fan in the background because it's that hot. So yeah, that concludes our experiment. So what did we learn? Which glass were able to produce ringing tones? Obviously all of them, because the thick glass is just lower frequency, therefore both glasses still produce sound. What factors affected the tones produced and why? Well, obviously the factors were affected is density, meaning the material is lighter. When the glass is lighter, means it can produce higher tone, higher pitch, different type of sound than to the thick one because it's lower frequency. We already discussed this. Elasticity, not really relevant with this glass, but it's more of like the vibration of the glass itself. And yeah, those were the factors. And then I don't know much to say about it. Therefore, yeah, thank you for listening, thank you for your time, and goodbye.